So again, the plate with a hole problem, thin plate with a hole problem, that is a plane stress problem, and the plate is being stretched with a uniformly distributed load. So now we'll be using ANSYS mechanical APDL commands. So you have to create a text file using Notepad or any other text editor, and these are the first few lines. Finish means any job, any ongoing job will be stopped. Then clear, the workspace will be cleared, and then you give title according to your requirement and preference. Then you are entering the preprocessor, and the name of the preprocessor is prep 7. So ET1 182, that means first you are using the element which has a number of 182, and that element is actually a 4-node quadrilateral solid element which is used for plane stress. So ET1 182. So this element can also be used for plane strain and axisymmetric analysis, but we'll be using it for plane stress. So you can check here ANSYS element 182. So plane 182. So plane 182 is to model 2D solid structures, plane stress, plane strain, generalized plane strain, or an axisymmetric element. Okay, nice. So ET means element type. Also you can search what ET is. ANSYS command ET, ANSYS command ET. So ET is I type, arbitrary local element type number according to the requirement of the user. ename means the element name or number as given in the element library in chapter 4 of element reference. So we are using only one element, one type of element, so it is 1. If somebody uses some other type of element, then he has to give ET2 and the number of his element, number of its second element. But for us this is sufficient. Then MP, material property EX, that means Young's modulus 1 to E5 in Newton per millimeter square, and MP Poisson's ratio 1.3. That means here we are using a single material, and that reference, our local reference number for that material is 1, and for that the Young's modulus, it is an isotropic element. So if you once you are giving only EX value, means EX, EY, EZ will be taken as same. So it's an and it will be taken as isotropic element. You are giving only a single Poisson's ratio, so it is a isotropic element with E and mu, and the value of U is 2E5 and this is 0.3. So again you can, if you want, ANSYS command MP. So MP label is valid element varied material property level. And what are the labels? These are the labels. So for us this EX is the labels, elastic modulus. Since we have not given EY, EZ, they will be taken same as EX. Okay, done. So now now the geometric model BLC4. BLC4 means a rectangle with two corners. This is the left corner coordinate, this is the width, and this is the height. So the rectangle is done, and this is the circle. So 0, 0 is the radius, and 10 is the 0, 0 is the center, and 10 is the radius. So file, so save the file and let me run it to see what has happened. So read input from, so the name of our file is okay, yes, so this has been created. So now we have to ASBA, that is subtract areas. This is a Boolean operation. So this is area number 1 and this is area number 2. So from 1 you subtract 2. How do you know this is area number 1 and this is area number 2? So you plot controls, numberings. So area number you switch on and see this is area 1 and this is area 2. So subtract area number 2 from area number 1. Also you can help ANSYS command ASBA. So NA1 area or areas if picking is used, NA2 area or areas if picking is used. ASBA subtract areas from areas. So this is done. Then mesh geometric model is over. Finite element model, smart size. Smart size we are using the finest one. So one you can again check the smart size command and how is it used, and a mesh, that is mesh area. A mesh means area mesh. Area mesh all. All means we have only one area, so that has to be meshed. So a mesh all. So the finite element model is over. So you can check intermediately, you save it, file, read input from, again this thing, yes, our mesh is generated. Now select and select the select node at location x0. Select and select means select node and keep it in a set at location x0. This is the syntax of the ANSYS command. So ANSYS command NSCL. ANSYS type item. So S, select a new set. So ANSYS S item, under item component vmin, vmax, kapps. So label identifying the data. So item for our is, for our case, the cell is at location. Item is location. Location can be, component can be x, y, z. So item then component. So item is location, component is x, and vmin is the minimum value, vmax is the maximum value. So for our case we are searching for nodes at location x equal to 0 and selecting those nodes. And now once it is selected, Now we have a set of selected nodes which have a location x equal to 0. Now all those nodes are being restrained in the x direction. So D displacement all the selected nodes ux equal to 0. Now again we are going back to ANSYS all, because now only a subset of all the nodes has been selected. Now again the full set of nodes are selected. So first a subset is selected which has a x value of 0 and ux is given a value of 0 there. Then again all the nodes are selected and select all. Now from there and select S, again selecting at location y 0, then D all uy 0, then again select, getting back all the nodes. So this select creates a set with location x equal to 0, then again reverting back to all the nodes, again selecting location at y equal to 0, then again giving a value of uy 0 to all those nodes, then again it is selecting all nodes. Then ANSYS again selecting ANSYS S loc x 200, that is where we have to give the pressure. SF for surface load for all selected nodes at x equal to 200, pressure of -1. SF means surface force at all selected nodes, because we have selected the nodes at x equal to 200. Now if you give all, then all the selected nodes will be given this value of pressure -1. Then again getting back all the nodes. So let's see, file save, let me run it. So file read input from, the name of the file, yes. So now the forces have been applied and it has been shown using a very thin red line. So what we can do is plot control symbol. So pressure convect, now it is being shown as phase outline, and we want it to be shown using arrows. So plot elements. So this is the full finite element model with boundaries and loads. So now, this part is over. So finish. So we are going out of preprocessor and entering the solution module. So our type is static. So and type 0 means static analysis. Then solve the current load step. Then finish. Then we are entering the post processor. Okay, before this let's see what has happened. File save, file read input from this. So solution is done. So then we are entering the post processor. General post processor is post 1. So now we are giving the path definition. So path command is there, path. So my path is the name given to the path, and it is being defined using 2 points. So again you can go and check ANSYS command path. So again, so here you will get according to alphabetical order. So all the commands you will get LMNOP. So yes, so path. So defines a path name and establishes parameters for the path. So path name is given by you, given by the user, number of points to define the path. So and the rest of the thing, so we want to keep as default. So path my path 2. And now the point specification, since 2 points we have given, we have to specify 2 points. So p path for point number 1 gap 0 10. Why is this gap? That will soon check. So point 2 gap 0 100 or 50, whatever, 50 0. So XY set. So to check this, so we have to see what is there in p path. So p path is here. So in p path defines a path by picking or defining nodes. We are just or locations. We are defining it by locations. P path point is point number 1, point number 2, and we are not giving node number, so we are keeping this blank. So the third entry we are keeping blank, then we are giving XYZ. So third entry we are keeping blank and XYZ. That means we are giving the locations, not the nodes. Also you can define path by nodes. But here one thing I have missed, you have to read the data set. So one append command has to be given. Then now mapping a variable on the path. So pdiff, any name you given, you can given my sx, and that is actually the stress in the x direction. So you can check the pdiff command, and let me save it and see what has happened. So again, so file, read input from, that's okay, solution is done, and we'll check whether the paths are defined or not. So path operations defined path, not defined path operation, yes, defined path is okay, plot paths, yes, the path is plotted. So this is our path. Okay, so path status, current path, so this is the current path, and my sx, so these are the values. Good, so path has been defined. Now you can just by command also you can plot, or from here also you can plot, whichever you wish. So path operations, okay, sorry, not path operations, yes, path operations, here plot, not paths, plot path items, yes, plot path items on geometry. Here we are actually my sx, we are plotting, give a high value of scale, and yes, it is this. So yes, this red value is actually 3.09, and this is the far field stress. Also you can plot it on geometry. So thank you.